Good morning, students. Once again, I welcome you to my video class. To continue with the 2019 EC paper, one more problem is here, and this problem is on DC transients. DC transients. DC transient. No doubt you have studied DC transients, but in this problem, the situation is different. The situation is different. In what way it differs, that I will explain that point. First, I will read the problem. The RC circuit shown below has a variable resistance RT given by the expression RT is equal to R0 into 1 minus T by T for 0 less than T less than capital T, where R0 equals 1 ohm and C equals 1 farad. We are given that T is equal to 3 R0 C and source voltage is 1 volt. If the current at a time t equal to 0 is 1 amp, then the current IT in amp at a time t is equal to T by 2 is dash. First, if resistor were not to be variable, then I would have written this expression. IT is equal to Vs by R e power minus T by Rc. This is the expression which holds good for current when R is a fixed constant. But the situation is different. In this problem, R is continuously varying with function time t. It is a function of t. Therefore, you can't apply this formula. Normally, students will remember this expression Vs by R e power minus T by R. This is charging current. But this cannot be applied. The reason is R is made variable. R is made variable. Now what I will do is first I will write R. What is R? R of T is equal to R0 into 1 minus T by T. R0 into 1 minus T by T. So T is given here. What is T here? T is 3 R0 C. As R0 is equal to 1, C is 1 farad, therefore T is equal to 3. Therefore, what is T by 2? T by 2 is 1.5. So T is 3 second, T by 2 is 1.5 second. Now I will write here as R0 is 1 minus T by T, that is 3. That is 3. Next, the next is you apply KVL to this path. We have to apply KVL. If you apply KVL, then 1 volt is equal to IR, or I will write Vs equal to IR plus the voltage across the capacitor is given by 1 by C integral IDT. Integral IDT is charge 1 by C. So it is based on this expression Q equal to CV. Therefore, V is equal to 1 by C into Q, or 1 by C into Q means integral IDT. Accumulation of current is nothing but charge. So Vs equal to IR plus 1 by C integral IDT. Therefore, 1 is equal to I into R. R is 1 minus T by 3. 1 minus T by 3 plus 1 by C. C is 1 integral IDT. Now you differentiate this. Differentiating, we get 0 is equal to. Now I is a function of time t, and I is function of time t, and here there is one more t here. Therefore, differentiating this we get I into I into minus 1 by 3 into 1. I am differentiating with respect to t. I am differentiating with respect to t, that is 1 plus di by dt into plus di by dt into 1 minus t by 3. 1 minus t by 3 plus 1 integral di by dt we get 0 is equal to minus 1 by 3i plus di by dt into 1 minus t by 3 plus I. Because dt cancels and the integral di means I. Now we have to arrange the terms. 0 is equal to minus 1 by 3i plus I. I will simplify plus di by dt into 3 minus t by 3. Therefore 1 by 3 di by dt 3 minus t plus simplify I minus I by 3, that is 1 by 3 di by dt 3 minus t plus 2 by 3 plus 1 by 3 into 2i, that is 2i by 3. Now transposing the terms we get transposing the terms we get and on this side 0. Now transposing to this side, minus 2i by 3 is equal to 1 by 3 di by dt into 3 minus t. So 3 get cancelled here. 3 get cancelled here, and I will rearrange the terms. di by I because I have to carry out integration. Di by I minus 2 into 1 by 3 minus t dt. di by I minus 2 dt 3 minus t. Integrating we get log to the base ei is equal to minus 2 log to the base. Now you know the formula for the integration. Log to the base e 3 minus t into minus 1 because there is a minus sign here. minus 1 plus log to the base e k plus constant k. Now taking this term we get log to the base ei plus log to the base minus log to the base ek is equal to minus 2. Now one can write this as minus into minus plus here, plus log to the base e 3 minus t whole square, because there is 2 here and this minus multiplied with minus becomes plus. Now log to the base e I by k, I by k, log to the base, log m minus log n is log n by n equal to log to the base e 3 minus t whole square. On both sides there is log, therefore you can cancel that, therefore what we get is I by k is equal to 3 minus t whole square. 3 minus t whole square. Now we have to evaluate this k, or I is equal to k into 3 minus t whole square. At t equal to 0, current I is equal to 1 ampere. It is given here. I is equal to 1. Therefore, 1 is equal to k into 3 minus 0 whole square, or k is equal to 1 by 9. K equal to 1 by 9. Now, having evaluated k, now you write the current expression as IT is equal to k is 1 by 9, 3 minus t whole square. Now we have to find the current value at t by 2. Therefore, I t by 2. So what is t by 2? T by 2 is 1.5 or 3 by 2. 1.5 or 3 by 2. Therefore, 1 by 9, 3 minus 1.5 whole square equals 1 by 9 into 3 minus 1.5 is 1.5 into 1.5 square. If you calculate, the current value comes out to be 0.25 amperes. This is the answer. So this is a problem on DC transients, but with a variable resistance. So the problem is getting complicated. The reason is because the R is also a function of time t. So both current and resistance are functions of time t. So when both are functions of time t, then we have to go through this type of procedure. So answer is 0.25 amperes. Thank you.